let's take a moment to zoom in on global IPv6 addresses. So here it says that they start with 2000:3 and they're assigned by IANA. So what does 2000:3 refer to? Well, let me write this out for you. If we have 2000/3, this means that the first 3 bits are set in stone. So what are the first 3 bits? Well, here, this is an entire field for hexadecimal values. So 2000:0:0, et cetera, et cetera, et cetera. Anyways, so what this is referring to is if we take that 2, what is the 2 in binary? It's going to be 0, 0, 1, 0, and then all the rest of the zeros are 0, 0, 0, 0. I'm not going to put in the rest of the zeros here because it doesn't matter, because here's the first 3 bits. So the first 3 bits are always going to be 0, 0, 1 right now. So what does that mean? It means that I can only manipulate every other bit after that in the entire address. So 2000:3 is referring to the fact that I have a range from 2000 to 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, etc. So in this case, if we look at the first field here is a total of 2000, but the first field here would be what? It would be 3000, wouldn't it? Or 3. Okay, it'd be 3 here. And then this would be equivalent to what? F, 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 and so on and so forth. So the range of values we're dealing with just right now for global addressing is from 2000 to 3FFF. So what about everything else? Well, a lot of it's just put aside right now for future use. In the upper range, in the Fs, so for example, like F, F, we're dealing with multicast. FE, we're dealing with link local addressing, and then FCs and so on and so forth. They all are reserved for other purposes. But right now for global, this is all we're playing around with right now. There's a lot of addresses in that particular range. And we can break it down further and further and further. So think about IANA right now, who is just messing around with 2000 to 3FFF. They can start subnetting that, breaking it up into smaller prefixes. So what they can do is they can assign out, for example, /23s. So you can take the 2000 range, 2001, 2002, whatever you want, and start breaking it up further and further and further. And you end up with a whole bunch of /23s. So if we're starting off with 3, and we go ahead and subnet down to a /23, well, how many different options do we have there? Well, there's 23 minus 3 is 20 bits. So we're playing around with 20 bits, 2 to the power of 20. So the total possible addressing there's a lot of addresses. And we're just plucking out of that right now 2003 FFF. So the regional registries get /23s, and then they can turn around and break that up into a whole bunch of /32s and hand those out to ISPs. And then ISPs will take the /32s and break them up whichever way they need to, and eventually hand out /48s to you. That's right. You are the site. You are the enterprise organization. So when you contact your ISP and you're trying to get IPv6 addressing, you'll be able to get a /48 from them. So /48 is essentially what enterprises are going to end up with. What does that mean? It means you have one /48 network. So let's say they give you, for example, we'll say 2001 colon DB8 colon 9 double colon /48. So that's what they've given you here. 2001 colon DB8 colon 9 double colon /48. So what now? Well, that's only one network, right? I'm pretty sure you're going to have more than one local area network in your organization. So what are you going to do? You're going to mess around in here. You're going to subnet. That's right. You're going to subnet. So what this means is you can go from a /48 down to a /64. So if we do that, how many bits are we playing with? Well, 64 minus 48 equals 16. 64 minus 48 equals 16. So let's make this a little clearer. 64 minus 48 equals 16. So we have a total of 16 bits. Well, what's 2 to the power of 16? 2 to the power of 16 is 65,536. Which means that when you get 1/48 from your service provider, you can subnet that into 65,536 /64 networks. And that's what you're going to do. So now you have a total of 65,536 different unique networks that you can deploy within your organization. It's more than what you need, probably. All right, so you're going to have some leftovers. You're going to have some spares. Are you going to subnet further than /46? No. No, not all. Because there's a lot of features that you'll learn about for IPv6 that rely on a /46 address. For example, stateless address auto configuration relies on a /46 address. So if you don't have a /46 address prefix, then you are not going to be able to use stateless address auto configuration. So that means, yes, we're going to have a lot of wasted addresses because even with a /64, here's your interface portion. So your interface portion is after the /64. So the first 64 bits, in this case, are the prefix. It's our network ID, and then the last 64 bits are reserved for the host in this case. So we have 2 to the power of 64 possible devices, possible addresses. And we're not going to deploy that many devices in a single local area network, especially with Ethernet. We're still bound by the way Ethernet behaves. So we still want to essentially have Ethernet networks that contain no more than 256 or 254 end stations. So with that in mind, yeah, we're going to waste a ton of addresses inside each of these 65,536 networks, but it is what it is. We have tons and tons and tons of addresses available to us. The only other recommendation they have is to subnet down to a /126 for your point-to-point Ethernet links, point-to-point serial links, whatever you may have in between routers as an example. So for local area networks, you're going to stick with the /64, but you might want to use /126s in between your routers in the organization. So you could do that. So just take one of these /64s that you have now, one of the 65,536 /64s, and essentially just subnet down to a /126, and then whatever subnet you get, there you go. You'll be able to use that in that case.